Okay, so changing these into improper fractions. Who would like to tell me what they did with number, well, not number, but the 2 1/3? Sean, what'd you do? 7 thirds? Yeah. And how did you figure that out?
I figured that out for making the two 3s.
Like this?
I did this and added 1 3.
1 over 1/3?
And then it equals 7.
So you knew that that was a whole, that's a whole, that's 2 of them, and then the 1/3 extra would make 7 thirds. Okay, who would like to do the second one? Nicholas.
6 fifths by adding 5 fifths plus 1 fifth equals 6 fifths.
And what made you decide to come up with this 5 fifths?
Because 5 fifths has the denominator as 5, and then if you put 5 over 5.
Okay, so he says he used the denominator 5 because we're working with fifths, and we needed to make a whole, so he did 5 fifths. All right, number, or 2 3/10. Let's do, what'd you do, Jaden? Okay, but 1 13/10 is another way to name it, but we wanted to make it a totally improper fraction. So this is still equal to this, but we need to find it fully, just a fraction and no whole numbers. What'd you get, Antonio, for that one?
23/10.
23/10 is what we're looking for. So, Antonio, can you explain to us how you found that?
I did 10 10 plus 10 10 plus 3 10.
There you go. So, 1 whole, the second whole, and then the fraction, and then we end up with 23/10. Okay, this one, Horace, 3 3/4.
15 fourths.
15 fourths, and how did you get that?
I did 4 fourths plus 4 fourths plus 4 fourths plus 3 fourths. But I just noticed right now that 4, like the denominator and the whole number, you multiply those and then add the top number.
Yes, that works.
And then
And that's something that works, and I had a couple students ask me if you can do it that way, and it is definitely, if you understand that, that's fine, you can do it that way. That does work, but I don't want people to do that unless they understand what they're doing. So I'm not going to elaborate more on that. But yes, you can do that. All right, this one, what did you get for this one, Luna?
5
Halves?
yeah.
Okay, why don't you tell me how you found 5 halves?
So I did 2 plus 1 half.
Okay, equals 5 halves, and that definitely does. How did you get this? The denominator is?
Denominator is 2, and you have to make it to that one.
Make a whole.
So you can make a whole.
Okay, so we did that. There's 1 hole. Here's another hole. How many holes should we have? 3. So how many, what do I have to do here? Another hole. And then, right, now what is that total?
7
Halves. Right, 7. There you go. Okay. And the last one, what do we have, Malia? 11. 6. Can you tell us how you work that out?
6 plus 5, 6 equals 1.
There you go. All right, turn to 7-8. Yesterday when we were doing subtraction, I said, oh good, you're going to be able to do the subtraction without having to regroup. Remember when I told you that? Maybe you do, maybe you don't. Today we're going to learn how to do the subtraction if the numerator of the top number is not large enough. So if I had 7, oops, we'll do this, minus 8/15. Right? If I had 7/15 minus 8/15, can you do that?
No.
No. So, or let's say I had 1 and 7/15 minus, let's say I had that. You couldn't do that yesterday. Today I'm going to teach you how to do that because you can do that. So, Bruce, Chandler, and Chase go bike riding on weekends. On one weekend, Chase rode his bike for 3 hours. Chandler rode her bike for 2 1/4 hour. And Bruce rode his bike for 3 3/4 hour. How much longer did Chandler ride her bike than Bruce did? How much longer? What mathematical operation am I going to do? What do you think, Bella? Subtraction. Go ahead and write it. In the problem, circle the numbers that you need to use to find the solution. So I'm going to go back to the question first. How much longer did Chandler ride than Bruce? Because we have Bruce, Chandler, and Chase. But we're only talking about Chandler and Bruce. So first of all, I need to find how far did Chandler ride. How far did she ride for, class?
2 1/4.
2 1/4. Everybody say that.
2 1/4.
Okay, and how far did Bruce ride, class?
1 3/4.
1 3/4. That's how we say it. So we're only working with those two numbers. We're not working with the 3 hours because that was Chase and he's not part of this problem. He's extra information. So we're going to be subtracting Chandler's ride minus Bruce's ride. 2 1/4 minus 3 3/4. Now last night's homework was nice and easy. We were working with subtract the wholes, subtract the fraction. It worked all nice and pretty. Today not so pretty, but that doesn't mean we can't do it. We're going to shade a model to show how far Chandler rode. How far did Chandler ride again? 2
1/4.
So here's the first mile. Here's the second mile. And here's the 1/4 of a mile. Go ahead and do yours. Okay, how far did Bruce ride? Go ahead, class.
1 3/4.
So oh, my green was left out and now it's not working. 1 3/4. Go ahead and do yours. All right, now we can look at our model and we can see what the difference is. How many portions are left over? What is the difference? What do you think, Tony? 2. And what is our size of our parts? 4ths. Right. So there's 2/4 left over. That's the difference. So Chandler rode her bike 2/4 of a mile longer than Bruce did. So we just did this problem. If we looked at it like this, we got scared. Because I can't do 1/4 minus 3/4, can I? But I just did this problem, and it worked. So look at how this problem does work, even though it doesn't work when we line up the numbers. Okay? If you have 1/4 size part, there's a 1/4 size part, can you take away 3/4 size? Can you normally do this? Oops, hold on. Can you normally do this?
No.
But what if you have some holes? Can you take from the holes?
Yes.
Do it. And explain what you think, why that might work. The first question I'm going to ask you was the top part. Can you do 1/4 minus 3/4 as it's written here? Can we do this, class?
No.
No, we cannot. We cannot do 1/4 and subtract 3/4 from it. If this is my example, I have 1/4. Can I take 3/4 away from that?
No.
No, so we cannot. No, we don't have enough. Okay. However, what if we have 1 whole and 1/4? Can you take 3/4 away from it? And I heard a lot of explanations in this. First of all, can you do that?
Yes.
Yes. Okay. I want you to think about exactly how do you make that happen. Okay, so let me say it again what he said. You can add the 1 whole as a fraction to the 1/4, and then you can subtract it. So if we're adding the 1 whole as a fraction, it looks like that. Right? Plus the 1/4, and then we get 5/4. So we're basically just changing it into an improper fraction, and then we can subtract it. We would end up with what, class? 2/4. Okay. Now, huh? It's weird, huh? Okay. So if you did not get to write that on your paper, rename the first mixed number to find the difference. So if we are looking at 5 1/8 minus 3 3/8, if I set it up like this, I'm going to set it up the way you guys have been doing it so it looks visually correct to you guys. Can I subtract 3/8 from 1/8?
No.
No, I can't. If I have 1/8, I cannot take away 3/8. So what we're going to do is we're going to regroup the 5, or we're going to rename the 5 wholes. We're going to rename them as 4 plus 1. We're basically going to take 1 whole and break it apart. Okay? So now we've broken down this 5 1/8 to 4 plus 1 plus 1/8. Is there anybody who is having trouble seeing how this still equals this? Okay. 5, what does 4 plus 1 equal?
5. Oh.
And then 1/8. So we're just going to take 1 away from this and call it 4 plus 1. Instead of calling it 5, we're just going to call it 4 plus 1. Does 5 and 4 plus 1 equal each other?
Yes.
Okay. So now we're going to take that 1 and we're going to turn it into a fraction. If we want 8s, the numerator has to be 8s. Okay, so we've changed this 1 whole into 8/8. It still equals 1 whole. And then we keep the 1/8 there. Now, if I rename this, we actually did this on the board earlier when Jaden gave us the 1 and 13/10. It's kind of the same idea. We're going to have 4, and how many 8ths are we going to have?
2.
No, I want you to look at it and not just say numbers out loud. We have 8/8 plus, we have 4, which I already put, plus 8/8 plus 1/8. What do we have as our fraction? 9/8. Okay, so we have a whole number and an improper fraction. But that improper fraction is going to make it possible for us to do some subtraction that we couldn't do a minute ago when we had it up here. So I changed the 5 1/8 to 4 9/8. That's what I just did here. And now I can subtract the 3/8, 3 3/8. So 9/8 minus 3/8 is what, class? 9 minus 3 is 6. And those are 8s. 4 minus 3 is
1.
And now I have an answer. 5 1/8 minus 3 3/8 is 1 6/8. And this is doing stuff that you guys already know how to do. There's no tricks, there's no secrets or no rules. You're just renaming your fraction and your mixed numbers as something else so that you can work with them.
Would we have learned this if we didn't have the...
Yes, but not as nicely. Okay. Trust me. You guys are doing way better this year than we did last year. Okay, so let's look at the next one. You can completely rename your fraction, your mixed numbers to be a full improper fraction. So we have, I'm sorry, let me start that over. You can completely rename your mixed numbers, like this, to be an improper fraction. So we know how to change 3 and 4/12 to just 12s because we did it on the board when we started the class. So right now I want you to take a second and rename the 3 and 4/12 as just a straight fraction with a bigger number on the top. Go ahead and take a second to do that yourself. What did you get as the numerator for this?
60, 40,
Oh,
30, 40.
let's look at why. I'm going to tell you why. I have 3 holes, and if I'm using a fraction, my holes look like this. Is there anyone who's not seeing that? I have 3 of them, so I have to do that 3 times. And then I have the fraction, which is plus 4/12. We just did this on the board, you guys.
Oh, great.
That's how we started our lesson. Now if I add those, 12 plus 12 plus 12 is 36. Plus 4 more is 40. So I have my fraction as 40/12. Okay, I want you to do the same thing with this one. Change it to an improper fraction right here. All right, what did you get as your numerator? 18. Very good. So this changed to 18/12. So now we're going to subtract the 40/12 minus the 18/12 and go ahead and do that on your paper. All right, what did you guys get? 22/12. Now can I change that back to a mixed number?
Yes.
I can. Go ahead and see if you can do that on your own. Change it back to a mixed number now. Our answer is 22 and 22/12. Change it back to a mixed number. All right, what did you guys get as your mixed number? 1 and...
10/12.
So we say 1 and 10/12, not 1 10/12, because that makes no sense. 1 and 10/12 is how we would change that back to a mixed number. Okay, look at the bottom. It says explain how you could rename 5, a whole number 5, so that you can subtract 3 and 1/4. Okay, there's 2 ways we can do this. We can change the 5 into a mixed number. So 4 plus 1. Does 4 plus 1 equal 5?
Yes.
Does 4 plus 1 equal 5, class?
Yes.
Now I'm going to change the 1 to a fraction. What fraction? I want to work with fourths because I have fourths over here. So what fraction do I need to change the 1 to, class? It's a 1. I need to change it to a fraction. What should I change it to? Andy? 4/4. Is this new?
Yes.
No, you guys, it's not new. You guys have been changing ones all week. You guys have been doing a great job with it. Don't make it harder than it is. Okay, so let me go back. I have 5. I want to rename it. I need a hole pulled out. Antonio, go. Yep, you can go work on it on your own. I want to change it to a fraction. I can change the 1 to 4/4. I still have the 4. But now I've changed this to this. So I have 4 and 4/4 minus 3 and 1/4. Can I do that now?
Yes.
What is 4/4 minus 1/4?
3/4.
And what is 4 minus 3?
1.
And there I have an answer. It's not any more complicated than what you guys have already been doing. So don't try to think too complicated about it. Just think of, okay, I want to pull a 1 out of here so that I can change that 1, so I can change it into a fraction so I can do the subtraction. That rhymed. All right, so now I'm going to try a different way. So this is one way. I can also change the 5 to a complete fraction. No mixed number. This is a mixed number right now because it's 4, it's a whole number, and it's a fraction. But I can just change it to an improper fraction. So if I want to change it to an improper fraction, what is my denominator going to be?
4.
And why do I want it to be 4, Jalen?
Because the other denominator is 4 and it's easier to subtract.
Right, we're working with fourths over here and we want to subtract. So I have 5 whole numbers. There's 1. There's 2. There's 3. Do I have to do more? 4, 5. Doesn't that equal 5 whole?
Yes.
So 1, 2, 3, 4, 5 times 4 is 20 fourths. Now I have to change the 3 and 1/4. So I'm going to move this. If I have 3 wholes, that's going to be 4/4 plus 4/4 plus 4/4 plus 1/4. What does that fraction equal?
16.
Not 16. Add them real quick. Raise your hand when you know. Shh. Angeli. 13 fourths. Now can I subtract 20 minus 13?
Yes.
It is
7.
7 fourths. Now can I change that back to a mixed number?
Yes.
7 fourths is 1, and then there's 3 left over fourths. So either way, I still get the same answer. I can change the whole number to a fraction, or I can just change one of the whole number. Go ahead and finish copying this down if you want to have that in your notes. The 3 and 3/6. What is one? There's 3 wholes. What fraction is going to be equivalent to 1 whole? Raise your hand when you can tell me. What fraction will be equivalent to 1 whole? Avani. We're working with sixths. So 1 whole is going to be 6/6. We did this on the board. This is how we started our lesson today, and you guys were all doing it. So I have 3 of those. So 6/6 plus
6/6.
plus
6/6.
plus 3/6. We have 1, 2, 3 wholes plus the 3/6. And that equals, go ahead and do the math in your head and raise your hand when you know. 21, 6. Okay, so that number's going to go here. 21. Go ahead and do that real quick. All right, we're going to change the 1 and 4/6 into a fraction. So I'm going to start with what for my 1 whole is going to equal
6/6.
plus
4/6.
4/6, which equals
10/6.
10/6, and I'm going to put the 10 here. Now I'm going to subtract 21 minus 10. What is 21 minus 10?
1.
11. 21 minus 10 is 11/6. Can I change that number back into a mixed number? Let's look at what that looks like. I can take away 6 out of this, remember? And I can end up with 6/6 plus what number? I have 11. I'm taking 6 away. How much is left? 5/6. So now I'm going to turn this into 1 and this 5/6. So this is my new mixed number for this. So 11/6 also equals 1 and 5/6. Look at number 2. Find the difference. Can I do 1 and 1/3? Can I do 1/3 minus 2/3? No, think about my question before you answer it. Can I do 1/3 minus 2/3? No, you can't, because if you only have 1, you can't take away 2. But I have a whole, and that whole I can change to make a fraction. When you know what my fraction I'm going to change that to is, raise your hand. If I change just one of these, what do I have left as my whole number here? 3. I will end up with 3 and 10/10 plus the 7/10. This is how it will start. And what is the whole number side? 2. That is the right answer. The reason is you take the 10 plus the 7 is 17. So you would have 3 and 17/10. 17 tenths minus 9 tenths is 8 tenths. And then the 3 whole numbers minus the 1 whole number here is 2. Okay, let's go ahead and do it if you made it a complete improper fraction. So this would be 10 plus 10 plus 10 plus 10 plus 7, which is 47 tenths. And this one would be 19 tenths. 47 minus 19, what'd you guys get for, is that the way you did it, Sean?
Yeah.
Jalen, what did you get for 47 minus 19?
28.
28 tenths.
Yeah.
And then did you change that back to an improper fraction?
Yeah.
Okay, so you know that 10, you can have 10 tenths plus 10 tenths plus 8 tenths equals that. So that's 2 and 8 tenths. You can change this fraction to a complete improper fraction, which would give you, you'd have 12 twelfths plus 12 twelfths plus 12 twelfths. That's our 3 wholes. But don't forget to add the 5 twelfths also. So that's 12, 12, and 12 is 36, plus 5 is 41. 41 twelfths minus 8 twelfths is going to be 33. Now I need to get this back to an improper to a mixed number. I can do 12 twelfths. If I take 12 from this, what do I still have left? I still have 21. Can I do it again?
Yes.
12 twelfths. If I take 12 from this, what do I have left? 21 minus 12. 9. So then I can't do it again. So then I have plus 9 twelfths. So this is 1, 2, and 9 twelfths. Okay? Or I can go back to here and I can just take one of these. So 2 and 12 twelfths. 3 equals the same thing as 2 and 12 twelfths. Now I add that 12 twelfths to the 5 twelfths, and I have 2 and 17 twelfths. Now I can subtract. What is 17 twelfths minus 8 twelfths? 17 minus 8 is 9. And then I have the whole numbers. 2 minus nothing is 2.